All right, you guys are halfway done with chapter 4. What we're going to do today is we're going to talk about Pythagorean theorem. Maybe you've heard of it, maybe you haven't, but I am on section 4.4 in the notes, right about in the middle of the packet. And what I need you to know about the Pythagorean theorem is it is a formula, and it can be useful because it helps us find the missing side in a right triangle. So first of all, you know what I mean by a side, right? I'm not talking angles. A side is one of the sides of a triangle. Okay, here's another one. I'm not talking angles, I'm talking sides here for Pythagorean theorem. Don't get those two things confused. There's a little bit of vocab that I need you to be comfortable with. First of all, we have this thing called the hypotenuse. It is the side that is across from or opposite the right angle. So anytime you have a right triangle, find the right angle, and the side across from it, this one, is going to be called the hypotenuse, and that is what we always use the letter C for, okay? The other two sides are the legs. So here's a leg, okay? So be really careful about labeling A, B, and C, because the formula is very easy to remember. A squared plus B squared equals C squared. Maybe you've seen it and heard of it and used it before. But what's important about that is that C is always the hypotenuse, and it is always the side that is across from the right angle. So this side, which happens to be the longest side, by the way, fun fact, is always across from the right angle, and it is always labeled C. Okay? The other two, the A and the B, you can switch those. B and A and B, that part doesn't matter. C has to be across from the right angle. Let's try a couple. I've got A squared plus B squared equals C squared. I'm going to label my sides. This is A. This is B, this is C. Make sure that the side across from the right angle is always the C. Okay, that is the important part. A and B can be switched. And I'm going to use this formula, A squared plus B squared equals C squared. That, my friends, is what Pythagorean theorem is. It's also right here. I wrote it right there. So let's see if we can figure that out. I'm going to start by writing the formula. A squared plus B squared equals C squared. I have A, which is going to be 6. So I'm going to put 6 squared. I don't know what the B is. That's the X. So I'm going to put X squared. And my C, I labeled 10.
5 minus 1.
Don't forget the squares. All right, so since I have everything plugged into my formula, remember I labeled my two legs, A and B, and I have to make sure that my hypotenuse, the one that is across from the right angle, that one has to be labeled C. And so I wrote my formula, and I have a 6 written next to A. So instead of A squared, I'm going to put 6 squared. Next to the B is my X, so that's why I'm having X squared. And next to my C is 10, so that's why I'm having 10 squared. Now, you might need a calculator, or maybe you know these numbers, but 6 squared, what that means is 6 times 6, it's 36. I'm going to keep X squared because I'm going to solve for that. And you people know what 10 squared is? I believe it is 100. And now I just have an equation that I need to solve. I'm going to subtract 36 from both sides, which cancels that. I've got X squared over here, and 100 minus 36, check me in the calculator, you get 64. And here's what you need to remember from Algebra 1. Everybody passed Algebra 1, which is how you got to geometry. In order to solve this for x, to get x by itself, you are going to square root both sides. When you square root a square, that is what cancels the square over here. And I just have x, which is excellent. And you can check in your calculator if you need to, but the square root of 64 is 8. The reason of that is because 8 times 8 is 64. Okay, let me try another one. Let's see, I'm going to put an A here, I'm going to put a B here, but I know that across from or opposite my right angle has to be the C. So that's what I'm going to put there. I am going to label my formula, A squared plus B squared equals C squared. Next to my A, I have an X, so I'm going to put X squared. Next to my B, I have a 15, so I'm going to put 15 squared. Oops, I wrote plus and I should have written equals, my bad. Equals. A squared plus B squared equals C squared. Next to the C, I have 17. Okay, so I'm going to put 17 squared. Now I'm going to use my calculator and I'm going to figure out what 15 times 15 is. It happens to be 225. I still have X squared here. And 17 times 17 is 289. You can check me in the calculator if you want to. Now I need to solve this. I'm going to subtract 225. And I got x squared over here. And when I subtract this, what do I get? 64. Okay, and just happen to be the same number here, but I'm going to square root both sides. That is how I cancel the square. The square and a square root cancel out, and I just get x over here. Square root of 64 in the calculator is 8, because 8 times 8 is 64. Okay, there's a couple more where I might have you draw the triangle and you have to label stuff, and I want you to be able to find hypotenuse. That's the C. That's the one across from the right angle, right? The C is the one that's across from the right angle, and they're telling me in the words of that problem that C is 15. Another thing says one of the legs is 9. One of the legs is 9. That means that I'm going to put a 9 here. And I need to figure out the length of the other leg. So I'm going to put an X there because that's what they're trying to get me to figure out, okay? I'm going to label one of these A and one of these B, and I've already got my C labeled there because the hypotenuse is always the C, the one across from the right angle. So now I'm going to use my A squared plus B squared equals C squared to solve this. Next to the A, I wrote 9, so I'm going to put 9 squared. Next to the B, I wrote X. Okay, so I'm going to put X squared. And next to the C, what do I have? 15. So I'm going to put 15 squared. Okay, now I'm going to solve this thing. 9 squared is 81. You can check it in the calculator. It's 9 times 9. 15 times 15 is 225. I'm going to subtract 81 from both sides. And I have x squared equals, what is 225 minus 81? 225, whoops. Clear, 225 minus 81, I get 144. And now how to get the x by itself here is square rooting both sides. That's what cancels my square. And the square root of 144 happens to be 12. You can check me with a calculator if you want to. I will save number 4 and skip it in the essence of saving some time. But that's how you're going to do those. You might have to label the sides yourself. And the most important thing is to make sure that you got the hypotenuse across from the right angle. That is the important part, you guys. The hypotenuse is the C. All right, one more formula that we've got. And yes, we will put this on a note card so you don't have to memorize it because it is kind of weird looking. But do you guys remember that when I give you an ordered pair, the first letter is X and the second letter is Y? And this is the first letter is X and the second letter is Y. That's how I give you ordered pairs. And this is my first X and Y because it's my first ordered pair. And this is my second X and Y because it's my second ordered pair. Okay? Now I'm going to use this formula, which looks really weird, but it's just weird because I have like a second X, there it is. And I have a first X, there it is. And I have some squares and some subtractions and stuff. So what I'm going to do is I'm going to copy the formula. I'm going to put a giant square root. And it's kind of like Pythagorean theorem. You have some parentheses squared plus another parentheses squared. Okay? And I also am going to put these minuses here. So now I just need to fill in my numbers, okay? All I did is I took the parentheses squared plus the parentheses squared. That's what I wrote first. And then I also copied these minus signs so that I don't get confused. Now I need to plug in my x1, my x2, my y1, and my y2. I'm going to do a different color here. Formula says to put x2 in this first spot. And what did I label x2 at? Okay, cool, it's 3. x2. x2 is 3, so I'm putting a 3 right there. Okay, the next thing in the formula is the first x. Where's the first x? All right, great. It is 1, so I'm going to put a 1 there. The next thing in the formula is the second y. Where is the second y? There it is. So I'm going to put, oh, it's a -2. Careful, make sure you bring the sign with it. And the last thing is the y1, the first y. That's a 2. Okay, great. I'm going to put 2. All right, now I need to solve this thing. So remember order of operations. Do you guys remember from like, I think it's the very first thing that I might have taught you back in August. PEMDAS. Parentheses go first, right? Parentheses. So that means inside the parentheses, I need to do 3 minus 1. That's 2. So 3 minus 1 is 2. And then inside here, -2 minus 2, you need to do that also. You can check your calculator. You get -4. And I'm just keeping this square here and I'm keeping this square here because I have not done exponents yet. The first thing I'm doing is parentheses, right? So I dealt with all the parentheses. Now I'm going to recopy the giant square root again, and I'm going to try and clean some things up. After parentheses, which I already took care of, is exponents. So now I'm going to do 2 squared. 2 squared is 4. Keep the plus. Notice I'm not adding yet. Adding is way down here. Okay, right now I'm just doing exponents because I already did parentheses, and next comes exponents, okay? What is negative 4 squared? It means negative 4 times negative 4, which is positive 16. Okay, now I'm going to do multiplication. Okay, there is no multiplication here. I'm going to do division. Also, there's no division. So I'm going to do addition now. Okay, great. 4 plus 16 is 20. And in my calculator, I believe Delta Math will have you round, I don't know how many decimals they're going to ask you for. But do you see above the x squared? Look at the x squared here in the left column. I can't really point to it. It's right here. See the square root? It's above the x squared. It's in blue, which means you have to hit blue x squared. But I'm going to put 20 in there. Enter. It gives you a decimal, 4.47. We'll have to check Delta Math and see what they want you to round it to, but it's 4.47. If it doesn't end up being a whole number, just leave it as a decimal, okay? That's enough for now. I'm going to skip the last one. We'll do it in class as a warm-up, but go ahead and get working on Delta Math and let us know if you have questions, okay?